Assalamualaikum to Dr. Abdul Hakim as our panel. We are from Chassis Department, one of the most important part in the project. The Chassis Department mission is to provide a strong chassis that are able to withstand the load and obstacle for the agriculture use. Based on the organization chart, our group consists of 5 students and Professor Madya Dr. Shahrul bin Abdullah Abdul Aziz as our advisor. I am SAIFUL bin JAMALLUDIN as the head of the department. NURUL binti Muhammad RUZAMI as research engineer, Shahriman bin Ibrahim as design engineer, ZULFAZLI bin SOFIUDDIN as safety engineer and FATIN BATRISYIA binti JUHAT as our operating engineer. Okay, I will explain briefly the job scope of every department. As the head of the department, I need to distribute the works among the members and assist it to follow the Gantt chart, so the work will run smoothly. Next, research engineer need to provide design analysis from the chassis and its production cost. For the safety engineer, he need to ensure the chassis is safe to use by always monitoring the design analysis. Design engineer need to identify manufacturing requirement and produce the best design for the chassis. Lastly, operating engineer need to provide solution to operational and accomplish mission of organization.
Hi, my name is Ain and I would like to share about our chassis. For the selection of material, we are using mild steel as it is most used for the terrain use vehicle like ATV. Meanwhile, as for the design of the structure, the chosen design is selected out of 3 choices. The evaluations were done based on the characteristic as the best design has the highest mark. After that, our part has a good safety system as the main part, which means that the durability of structure is really important in producing the best chassis for agriculture use. As it becomes the main part, it must be able to support other excellently without disturbing other components to function properly. Then our chassis is able to withstand obstacles as it will face different terrains which require it to be strong and durable. So, it is clearly stated that the user having a problem on choosing the best design for them and to find the best material. Besides, the problems for this project is either the cost for making the part will exceed the placed budget with all the required characteristics for the best chassis. Therefore, the purpose is to allow for terrain use which is strong and suitable for maximum yield strength, which is 2.2 to the power of 8. Most of the user is from baby boomers generation. Since they are more exposed to a high risk of getting injured, therefore the safety of product has become their main priority. So, our chassis is the most suitable as the safety factor is more than 3, which promotes a high safety to the user. Next, the elasticity of modulus for our chassis is 210 GPa, which can support others greatly and can withstand high load with a very small deflection. These are minute meetings which held through WhatsApp and Google Meet platform. All members will participate and everything planned is on track.
Hi, Assalamualaikum. My name is ZULFAZLI and I am here to talk about our benchmarking based on the criteria needed for a perfect ATV transplanter chassis. So these are the designs we generated. So let's break all this down quickly. So the first one is much more easier to fabricate and much lighter compared to the others. The design number 2 are more aesthetic and rare since it is just one of a kind and has a medium number of parts to weld, so it is not too complicated. Moving on to the chosen design that have a long compartment and structure base to fit the engine in and more comfortable. It also has a pair of footrests to prove our comfortable point as I said just now. Looking down to the per chart, the selected design has massively scored plus 17 points by setting the important criteria as the datum. As the design usually outscored its rivals, then we assume it is an easy choice. As additional content to our presentation, we already considered some of the designs for our cover set later on after all the parts are combined together. So these are the conceptual design, also based on the design that already available in the market. The Tesla is looked to be much suitable for agricultural purpose, and with its simple design, it is also easier to fabricate and indirectly reducing the cost. The Kawasaki also has sleek design and sporty, but they are much heavier compared to the others. The last one is Yamaha, which has sporty design and look very interesting, but this design is too complicated and by that it will be much costlier to fabricate. So by that case, we already made our decisions and we are going into the best design of them all, which is the Tesla Cyberport design. This will be the conceptual design for our ATV transplanter cover set. Well, I think that's everything from me. Thank you.
For the product design specification, the chassis must can to withstand force used in terrain like agriculture use. The structure of the seat also need to be ergonomic so the workers can do the job in a long time. The cleanliness of the stress must be ensured to make the chassis maintenance free and can use it in a long term. For the safety, the assembly for the chassis must be secured and can to withstand force when assembly with the other parts. For the competition, most of the ATV are for racing purpose and not for the transplanter use. The product produced in this department is the chassis for the transplanter with the maximum weight 19.7 kg, 76 cm length times 60 cm wide and 50 cm height is the overall dimension for the chassis, and the material used is mild steel, round hollow tube and square hollow tube. Welding, cutting and drilling are the manufacturing process, and around RM250 is the maximum cost estimation for the chassis.
Alright, I will continue our presentation for the next slide. Since my role for this project as design engineer, then I will explain more about the design for the chassis. First, for the stress analysis, we had been made a few analyses on this 3D chassis frame model to find whether this design is suitable enough to use for our ATV or not. Actually, there are 4 types of analysis that had been conducted on this 3D model chassis frame, which are static analysis, impact analysis, turn left and turn right static analysis. All the analyses that been conducted are using the SolidWorks software, since this software can give the best result and highest accuracy for information needed among other software for 3D model design. Furthermore, SolidWorks also is the easiest software to conduct since this software updated every year. So it's really up to date based on the industrial needed. For the work of the chassis, actually in SolidWorks we can set the type of material that can be applied for our product. We decided to choose mild steel since this material is strong and durable. By using the features in SolidWorks, which is mesh properties, eventually we can finalize the work for the chassis frame that had been designed, which is 19.747 kg, which is around 20 kg conclusively. By using mesh properties also, we can actually find the total weight of wheel bit that been produced from the welding process, which are 449.25 grams. This information can help us to calculate the theoretical analysis for the chassis. The first analysis that been conducted is static analysis. So basically, this analysis is to determine the critical part whenever the work of engine and a rider are applied on the chassis frame. The fixed conditions are applied at the below points of the chassis, since it is the closest part to the ground. The load of the rider and the engine are distributed at the seat and engine part, which are 418.23 newtons and 264.78 newtons respectively. As we can see on the result, it shows that the area bounded by the red color shows that the stress is at the most critical, which is 1.839 times 10 to the power of 7 newton per meter square, while the blue color indicates the least amount of the stress, which is 1.533 times 10 to the power of 6 newton per meter square. Only around 5% of total chassis part is the critical point, which are red color. Second one is the impact analysis. So commonly, impact analysis is to determine the critical part of chassis that involve whenever the ATV are hitting any obstacles from the front chassis. The fixed conditions are applied at the front of the chassis to act as the obstacle, while the load distributed from the transplanter, which is 400 newtons, are applied at the back tail of the chassis. The result shows that the area bounded by the red color experienced by the part is at the most critical part, which is 1.152 times 10 to the power of the 7 newton meter square, while the blue color indicates the less amount of the stress, which is 10 times 10 to the power 5 newton per meter square. Only 5% of the chassis are at the critical point, which indicates the critical part from the transplanter whenever the force is applied. Lastly is the turn static analysis. For the analysis, we perform two conditions, which are when the ATV turn right and another one when the ATV turn left. We assume 260 Newton force applied at the both sides of the front chassis. The result for both analysis is quite similar since the design for both right and left side is same. For turn left analysis, the red color that indicates the most critical part is 9.173 times 10 to the power of 6, while the blue color indicates the least amount of the stress, which are 7.644 times 10 to the power of 5. For turn right analysis, the highest and critical point is at 9.192 times 10 to the power of 6 Newton meter squared, while the least amount of the stress is 7.660 times 10 to the power of 5. The yield strength of mass that applied for all analysis is 2.206 times 10 to the power of 8. As conclusion, all the analysis is conducted successfully.
Now, we move to the calculations. We prove the ability of our product. It is assumed that the speed is 65 km per hour and the force is 193.257 Newton. From here, value of deflection identified at certain time and speed. Besides, we are able to obtain the work done and the allowable force before it fails. Now, the calculations are for two sides. The distance for it to deflect after maximum allowable force is applied to front impact is 2.709 meter and 50 seconds, while the side impact is 5.418 meter and 3 seconds. The work done for both sides are same, which is 32.6 kN. However, the allowable force obtained for front is higher than side, which allow for more force act on it.
For drawing of the components, I will explain each of the components part by part, starting with the full chassis. So basically, this is the full chassis drawing. We can see the top view, the side view, and the front view of the chassis. This chassis consists of 4 parts that been assembled, which are the main body frame, the middle connector, right and left footrests, and lastly the back tail. The dimension for the chassis is basically quite similar to the common chassis ATV that have on the market. We designed this chassis based on the centimeter measurement since it is the easy to assume and build the chassis. As we can see on the slide, the main body frame for both left and right side are the same. The maximum height for this body frame is 45 cm, while the length is 80 cm and the width is 20 cm. The main frame chassis also using the hollow mild steel pipe, which is 2.96 cm according to the ANSI condition. This is the drawing of the middle connector. The function of this part is to connect both left and right side of the main frame. The length for this connector is 20 cm and the steel used is 2.96 cm hollow mild steel pipe. The length of this connector is suitable for a rider to sit comfortably on the chassis frame. Next one is the drawing of left and right footrest. Both of the sides has the same dimension. Basically, the dimension of this footrest is according to the average size of the human feet. This part is using 2.16 cm hollow mild steel pipe, which is according to ANSI standard. It will be welded at the below of the chassis by using the arc welding or spot welding. We decided to make the footrests are fixed to the chassis since this ATV will be used at off-road and extreme condition, so it needs to be strong enough to stick with the chassis. Lastly, for chassis part is the back tail. From the drawing, we can see the length of the back tail is 19 cm and the width is 20 cm, same as the width of the chassis. This part will be the connector for the transplanter to the body chassis. We're still using the same hollow mild steel pipe same as the main body chassis, which is 2.69 cm according to ANSI standard. We move to the next slide, which is the drawing for the cover set. The first one is the front cover set. This part will be put at the front of the ATV. The concept design for this cover set is from the Tesla ATV. The dimension for this part is according to the condition and position of the other part that assembled to the chassis. Lastly is the drawing for the middle cover set. This cover set is combined with the seat of the ATV. The dimension for the seat is suitable for single rider only since this ATV is designed for off-road and not really suitable for common road. So it's enough for only single rider. The hole at the middle of the cover set are actually as the hole for the steering. All the cover set part will be assembled to the ATV by using bracket. The total weight for all cover set parts around 7.56 kg only since it is made from aluminium plate. Okay, now I will explain about the exploded view for this chassis. Exploded view can be defined as the individual parts of mechanism separately but indicates their proper relationship. So generally, this is the exploded view drawing of our chassis. The total of components that been assembled to build this chassis is 44 parts, including the additional part to connect the absorber and the main chassis. This is the bill of material for our chassis. Bill material can be defined as the comprises all the assemblies and parts required to construct a product. So our bill of materials are based on the drawing of the exploded view before.
Assalamualaikum. I will explain about project costing for the chassis department. The main material for our chassis ATV is mild steel. It is because the availability of the material in the market is high. Moreover, the price for the mild steel is considerable for our budget. Despite that, its mechanical properties are suitable. Here is the cost for chassis materials. The price per meter depends on the dimension of the mild steel. The total cost is Rm176 ringgit. Our survey was based on online website. Because of certain limitation, we were not able to do the survey physically. These are lists of our website used to survey the price that we had stated earlier for mild steel. All the website based on Shopee. The 33mm x 1.9mm is for main chassis body, and 27mm x 1.6mm is for the footrest. This is an example for page of the website that we surveyed. This is the level cost for chassis department. The indirect costs for the project are assembly, welding, cutting, grinding, and drilling. Manpower for welding and assembly are put to 3 people because of this process is quite complicated from other processes. Most of the fabrication process is by the student. Because of that, pay per hour was set to Rm2. This is the financial status of our department. The current asset is the cash, of which are Rm400 ringgit, which is the budget. The current liabilities that we need to settle down is the material cost and labor cost, and make it the total liabilities about 246 ringgit. From this, we know that the cost is within our budget.
Before we end our presentation, we will present our video of fabrication process for our chassis. Please enjoy it.
Titanic, ice blue like the Atlantic, and I'm going down like the Titanic. Like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic.
It wasn't all romantic. Stay hungry, stay foolish. It was their farewell message as they signed up. Stay hungry, stay foolish.
Like the Atlantic, and I'm going down like the tide. Like the Atlantic, and I'm going down like the tide. Like the Atlantic, and I'm going down like the Titanic. Like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic. Like the Atlantic, and I'm going down like the Titanic. Like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic. Ice blue like the Atlantic, and I'm going down like the Titanic. Atlantic and I'm going down like the Titanic. Like the Atlantic and I'm going down like the Titanic. Blue like the Atlantic and I'm going down like the Titanic. Eyes blue like the Atlantic and I'm going down like the Titanic. Eyes blue like the Atlantic and I'm going down like the Titanic. Blue like the Atlantic and I'm going down like the Titanic. Eyes blue like the Atlantic and I'm going down like the Titanic.
It wasn't all romantic. Stay hungry, stay foolish. It was their farewell message as they signed off. Stay hungry, stay foolish.
Like the Atlantic and I'm going down like the Titanic. Like the Atlantic and I'm going down like the